Our project focuses on developing a new type of navigation device for the blind. We know that blind people can only perceive the world by senses of hearing and touch, and most blind people use a walking stick to interact with surroundings and detect obstacles, which is neither convenient nor safe because of the very limited feedback. So if they want to experience the world like normal people, they definitely need more assistance. In recent years, with the development of the depth sensing technology, people have come up with ideas to develop navigation devices with depth sensors and sound systems. By processing the depth image captured by the depth sensing camera, now researchers in computer vision field are able to recognize obstacles and then let the users know the positions of those potential dangers through generating voice or sound feedback. With obstacle detection, this kind of navigation systems can improve the safety of blind users, but they have to meet the heavy computational needs of the image processing. More importantly, rather than having a basic obstacle avoidance approach, blind users are eager to gain more information and get an overall understanding of the environment. Therefore, our idea is to make full use of the sound characteristics like quality, pitch, and loudness to convert the depth information into a 3D audio format. Unlike those proposed devices that lay much attention on image processing, we dig more into the mapping system and present the raw data as much as possible for user processing, because we believe in terms of information processing, humans are still much better than computers. So with proper training, our user can be adept at processing the sound and reconstructing the depth map of the environment they are facing. Our navigation system consists of a depth sensor and a PC. For the depth sensor, we choose Z stereo camera because it is portable and of a good quality, with depth perception up to 20 meters. And we generate 3D sounds on the PC by using 3D sound APIs such as Fmod. Now let me pass the time to my teammate and he will go into details of our system architecture and algorithms.
Okay, for the system design, generally, we extract the information from depth graph and convert it into sound information for the blind user. By using our system, user will hear the periodic sounds that indicate the environment situation. For each cycle, there will be three sounds for the left, middle, and right, and one quiet period for user to identify the cycle. With proper training, user can be aware of the environment and potential obstacles. And our system is designed based on two major parts: extract the useful information in the depth image and map the information into audio faithfully. In the image process part, we reduce the border information so that user can focus on the front view. And then we divide the image into three parts horizontally. And there will be one sound to demonstrate the situation in each block. For each block, we calculate the average distance from the same height and reflect it by frequency and loudness. In the sound mapping algorithm part, we first use time multiplexing to generate three sounds which map to the left, middle, and right block. Then we use three kinds of sounds to generally split the distance by smaller than 1.5 meters, 1.5 meters to 5 meters, and larger than 5 meters. And it sounds like user will get a general concept of the distance of the object by identifying the type of sound. To further increase the accuracy, we map the distance with frequency and loudness to each single sound. The closer the object is, and the higher frequency will be, and the louder the sound will be. Thus, if you have a block that is 1 meters away from you on the left bottom, you will hear a sound one time with a frequency from high to low, and other situation is shown in the graph. With the proper training, user can easily identify any potential objects and be very clear about the surroundings by keep listening the audio notification. And when user adapt to our system, we can increase the steps of sound cycle so that user can work fast enough with the help of our system. For the real-world testing result, let me pass to my groupmate Geoffrey to introduce it.
After we design and implement our system, we try to evaluate our system to see whether it works or not. The experiments are taken under several cases, which are both the most challenging cases if a blind man wants to navigate from one room to another, including walking the corridor, miss a wall and then swerve, go upstairs, and then facing obstacles. Now let's see these experiments case by case. For the first case, that the blind man is walking through a corridor, in both the left side and the right side. The blind man knows that it is very close to him because the distance is less than 1.5 meters, which is not walkable. And for the middle block, the distance is more than 1.5 meters. Also, the frequency drops down and then rises up. The blind man knows that this block is a corridor and walkable. The sound can be heard as follows. For the next case, when the blind man meets the wall, our system detects that all the distance of 3 blocks are less than 1.5 meters, and also the frequency of each block does not change. Because in our system, the frequency stands for the distance, so the blind man knows that there is a wall whose distance is less than 1.5 meters in front of him, or at least there is a huge obstacle. So in this situation, he needs to swerve left or right to see which direction he should go. And now the blind man decides to look left and look right. When he looks right, he finds that the distance of the left and the middle block are more than 1.5 meters. And for the right one, it is not walkable because the distance is less than 1.5 meters. Now the blind man can have a brief image in his head that there is a wall in front of him, and when he turns right, there is a corridor. So at this moment, he decides to turn right. Another challenging case is the stairs. And now let's see how our users can detect the upstairs from our system. Whenever a blind man stands in front of the upstairs, firstly, the distance of 3 blocks are both less than 1.5 meters, which is similar to the wall. However, in each block, extremely in the middle one, the frequency drops down gradually, which sounds like a drill. This down pattern stands for the upstairs, so the blind man then will try to touch the handrail and go upstairs carefully. Lastly, let's see how our system detects obstacles like human. When the blind man is walking, a boy is also walking directly towards him, and when the distance between them are less than 1.5 meters, the sound pattern of the block will suddenly change. And in this case, the sound pattern will change from sound 2 to sound 1 to alert the user. Also, the user can know the height of this obstacle by finding the turning point of the frequency. Then the user realizes that the obstacle is much higher as him, so he knows that there may be probably a boy in front of him. Through the experiments, we find our systems really workable and in the right direction. So we try to make some improvements to make it perfect. Firstly, we will try to improve our sounds by adding some spatial features to let users feel that they are hearing a sound rising from bottom to the top. And also, we want to make it more user-friendly by combining different frequencies into one, just like a violin. Secondly, we want to do more experiments to evaluate how our system works in some extreme cases, which can help us to find the limitation of our system. Also, we will evaluate our system in a continuous experience instead of some challenging experiment cases. Lastly, for now, our system will generate the sound from left, middle, and right orderly. Sometimes users do not want to always know the information of all 3 blocks. Instead, want to know more about the blocks which is closest to him. In the future, we may shuffle the order of sound. For example, the middle one is closest, may generate the sound of left once, middle twice, and right once.
好，棒了，关系。先试一遍，简单的试一遍。
先停一下。
这个音乐的放